Here we have a SAT math question. Okay, let's go with the information. Negative 4x square positive 1 and 12x positive 42 is equal to negative px positive w. In the equation given, p and w are constants. The solution set of the equation is w over 2, comma negative w over 2. What is the possible value of w? Okay, for the equation given over here, there are two solutions. So one is w over 2 and other one is negative w over 2. And we have to find the value of the constant w. Since w over 2 is one of the solutions for this equation, what we can do is we can plug in this w over 2 for x over here. In that case, the w over 2 will satisfy this equation because it is one of the solutions. Okay, now let me plug in the first solution w over 2 for x in this equation. Then I'm getting negative 4 times w over 2 whole square, positive 1 and 12 times w over 2 positive 42 equals to negative p times w over 2 positive w. Okay, negative 4 times when I square a fraction, I have to square the numerator and the denominator both. When I square the numerator, I am getting w square. When I square the denominator 2, it will become 4 positive. So here we can simplify this 1 and 12 times w over 2. That is 2 goes into 2 1 times and 2 goes into 1 and 12 56 times. Then I am getting 56 w positive 42 equals to negative p times w over 2 can be written as negative p w over 2 positive w, and here this 4 will cancel out. I'm getting negative w square positive 56 w positive 42 equals to negative p w over 2 positive w. And also this negative w over 2 is also another solution for the same equation. Since this negative w over 2 is another solution for this equation, we can plug in this negative w over 2 for x, like the stuff what we have done over here. Okay, let me continue. So now I'm going to plug in negative w over 2 for x in this equation. Then I'm getting negative 4 times negative w over 2 the whole square, positive 1 and 12 times and negative w over 2 positive 42 equals to negative p times and negative w over 2 positive w. Okay, negative 4 times. Since we have even exponent over here, the negative sign inside the parenthesis will become positive. And whenever we have an exponent for a fraction, the exponent can be taken for numerator and denominator. And also this negative will become positive because of the even exponent. Then I'm getting w square. When I take the same exponent 2 for the denominator 2 over here, it will become 4 because the value of 2 square is 4. And here 2 goes into 2 1 times, 2 goes into 1 and 12 56 times, and positive times negative is negative 56 w positive 42 equals to, now we can multiply this negative and negative, it will become positive pw over 2 positive w. So here this 4 will cancel out. Then I'm getting negative w square negative 56 w positive 42 equals to pw over 2 positive w. Okay, now what we can do is we can add these two equations, the equation over here and the equation over here. So when I add the two equations, I'll be able to get rid of the term which contains p. So because here we have negative pw over 2, here positive pw over 2. When I add the equations, I'll be able to get rid of the term which contains p. Then we'll have the equation only in terms of w, and we can find a possible value of w. Okay, now to add these two equations, so let me keep this equation as it is, and let me write this equation over here. Then I'm getting negative w square positive 56 w positive 42 equals to negative pw over 2 positive w. I have written this equation over here. Okay, now let's do some simplification. So this positive value, negative value will cancel out, and negative 56w, positive 56w will cancel out. So when I combine negative w square, negative w square, I'm getting negative 2w square. And when I combine these two values, I'm getting a positive 84. And on the right side, w and w, when I combine the two w's, I'm getting positive 2 w's. Okay, here I have a quadratic equation in terms of w. So we can get this equation in standard form. That is, we have to get everything on one side of the equation. On the other side of the equation, we must have 0, so that it will be easier for us to solve. So for that, let me subtract 2w from both sides. When I do so, this positive 2w, negative 2w will cancel out. I am getting negative 2w square, negative 2w, positive 84 equals to 0. Okay, now I got everything on the same side of the equation. On the right side, I have 0. Okay, now let me erase other stuff and solve this quadratic equation for w. Okay, let's continue. This is a quadratic equation. I got it in my previous work. Okay, here when I look at the coefficient of w square, the coefficient of w and the constant, everything is a multiple of 2. So, and also since the coefficient of W square is negative 2, we can factor negative 2 out. When I factor negative 2 out, then I'm getting W square positive W negative 42 equals to 0. Now we can distribute this negative 2 to each term inside the parenthesis and check whether we get this stuff. So to confirm the factoring, what we have done is correct or wrong. So when I distribute this negative 2 to W square, I'm getting negative 2 W square. When I distribute this negative 2 to positive W, I'm getting negative 2 W. When I distribute this negative 2 to negative 42, I'm getting positive 84. So the factoring, what I've done is correct. Now I can divide both sides by negative 2 to get this negative 2. Okay, let me divide both sides by negative 2. This negative will cancel out. I am getting W square positive W negative 42 equals to 0. Okay, now we can try to solve this quadratic equation by factoring. So for that, I have to multiply this constant of negative 42 by the coefficient of W square. In this case, it's 1. When I multiply this negative 42 by this 1, I'm still getting negative 42. So now I have to get two factors for this negative 42, so that the sum of the two factors is equal to the coefficient of W. In this case, it's positive 1. I think positive 7 and negative 6 will work. When I multiply positive 7 and negative 6, I'm getting negative 42. When I combine them, I'm getting positive 1, which is a coefficient of W over here. Further, I have to divide both these factors by the coefficient of W square, that is 1. So when I divide positive 7 by 1, still I'm getting positive 7. When I divide negative 6 by 1, and still I'm getting negative 6. Now to get the two values of W, what I have to do is I have to change the sign of each of these two factors. Okay, now to get the first value of the W, I have to change this positive sign, then I'm getting negative 7. To get the second value of W, I have to change this negative sign, then I'm getting positive 6. So the possible value of W is negative 7 or positive 6.